Welcome to Luca and Miguel. Enjoy the video.
You start by preparing a reproducible environment. Create a Python 3, 8+ virtualenv and install OpenCV, TensorFlow or PyTorch, NumPy, and helper libs. This ensures consistent behavior. Next, gather labeled images for two classes, masked versus unmasked, and structure them into train, val, test folders so you can iterate quickly. Once done, write a small data loader using OpenCV to read. Resize to 224 x 224, normalize pixels, and yield batches. This gets you ready to train immediately. Now you build and train. Instantiate a pre-trained MobileNet v2 or ResNet 18 as backbone, replace the head with a dense 2-class softmax, and freeze initial layers for a few epochs to stabilize learning. Apply real-time augmentation, horizontal flip, small rotations, brightness jitter, so the model generalizes to varied faces. Train with categorical cross-entropy, batch size 32, use a learning rate scheduler and early stopping. Once validation stabilizes, unfreeze and fine-tune a few layers to squeeze out extra accuracy. Finally, export and deploy your detector. Convert the trained model to ONCs or saved model for optimized inference. Load it with OpenCV DNN or TensorRT for real-time throughput. Implement a webcam pipeline, detect faces, crop, preprocess, run model, then draw bounding boxes and label mask probability on the frame. Make sure to smooth predictions across frames to reduce flicker. If results degrade, inspect class balance, normalization mismatch, and confidence thresholding. Fixing these resolves most issues quickly.
Thanks for watching and please subscribe. It's the best investment you'll ever make.